This video covers the 5 major areas of where a model railroader can get into trouble when dealing with roadways on their model railroad layout. This video will also get into how to address each of these areas and to overall try to help you, the modeler, improve realism on your layout. The first don't is not doing adequate planning for your roadways when laying out your track plan. When you're laying out your track plan, remember it's really a layout plan, not a track plan. So you need to be figuring out where roads goes, river goes, where you think major structures will go. Because if you don't, you're going to end up with potentially trying to shoehorn roads in, and that's where things are going to potentially be starting to get unrealistic, and will end up violating, or you'll end up creating the don'ts that'll be explained in the rest of this video. From my layout here, I'd assumed that following the single track here that we were going to put a roadway in here, serving these residential homes here and industrial access over here. But I didn't know how much width it was, and I was just making a guess. And in reality, when I started this originally sketch, I thought maybe I could put 4 houses here. In reality, I can only put 3 because the roadway, once I figured the actual width of the roadway and room for parking, and then for the sidewalk, there was actually needed to be more room. So I really had to sacrifice things. But it's important, really to have a lot of times less is more. So don't try to overcrowd structures and everything else. And the same thing here, we wanted to have a road crossing somewhere in here, but not until I figured out where this road was, where I could figure out where the rest of this industrial access could actually get to, and where it needed to go. And likewise, I actually ended up having to shuffle around where all of these ramps went in order to get enough access and room for trucks to turn around and access the ramps and access these industries. A lot of times you may actually have to do some maneuvering around once you get down to that final level. But at the earliest point, make sure you allow the room first. The second don't is don't make roadways too narrow. And this ends up being one of the more problematic areas for many model railroaders, is that roadways tend to make them too narrow, where you could be difficult to pass vehicles and trucks, as an example. Roadways need to be consistent with what you're doing. Potentially you could have rural roadways or urban roadways, and depending on the context of what they're trying to represent, will determine whether you can get away with something narrower. Show here on the screen are a couple of cross sections, both one of which is a urban cross sections. One here is a two-lane roadway with parking, following it as typically might find in a central business district, especially on model railroads. And the second one is a 3-lane with no parking, but with a center turn lane, which might be common for a commercial strips. This is where your fast food restaurants and things like that would be. And also feel free to stop, pause, make a screenshot of these for your reference later. In the second here is the second of rural cross sections, where we're showing here a 2-lane rural roadway with paved shoulders, and a 4-lane divided highway. And you note that you can have a variety of widths, and especially for shoulder widths, they can vary from no shoulder to local roadways 2 feet. 4 feet's pretty common. Modern highways and freeways like interstates, you could be 6 to greater, up to almost 10 feet. Lane widths, again, using here the typical 12 feet for highways, and more modern cross sections for city streets. However, a lot of city streets were laid out a lot earlier than this, so use of 10-foot, 11-foot lanes are also appropriate. And here's an example here on the current layout where I've kind of penciled this in here. We have a roadway here serving in a kind of a mixed area where we have houses on one side of the street, industrial on the other, and we're having generally here there is two two 11-foot lanes here. And then also here in the dash line here, we've also drawn in here an 8-foot parking strip. We have parking, you need about 8 feet for cars. So you can see here, this car here is fitting nicely in between this dash line here and the solid line here for the overall strip for parking. And then if you have 2 lanes vehicles here, you can see that these 2 vehicles here will pass each other and with appropriate amount of space to the edge of the roadway and between where the lane lines would be. The third don't is don't make curves too tight. And this applies to roadway curve in itself, or a horizontal curve, but it also works with driveways, different access roadways, and also around truck loading and unloading areas and intersections. The easiest way to do this is really get a particular design vehicle of choice, and typically a design vehicle for most is going to be your tractor trailer truck of the period. Now here I'm modeling here the mid 50s, so a tractor trailer with a 35-foot trailer is appropriate length. If you're modeling 1960s, a 40-foot trailer. Into the 70s, 40-foot trailer also works. In the 80s, a 45 or 48-foot trailers, and then up to the 90s and up to the present day, the 53-foot trailer. You really should take a vehicle like this and actually do some play here to make sure. I'm going to move this track here clearly. You want to make sure that can you actually move your vehicle, and these trailers will off track a bit. While the steered axle is here, the trailers will kind of follow their own curve. So we want to make sure, can you actually turn around these corners and around your intersections here without really going off into the opposite lane or dragging on the shoulder. I originally, for instance, had this curve here, this curb radius here being too tight. If you come around the corner here, this truck here, you see you dragging across the line here. So what I've done here now is I have the intersection flare here going clear out to here. So this truck is going to be kind of over here pointing this way, and then it's going to head this way, and it's going to basically stay more or less in its lane without worrying about going over. So you can do the same thing with your vehicle here around all of your loading docks, and see, can you actually get that vehicle in there, straight in there with multiple point turn. And it makes you kind of just drive your roadways to see if you can fit or not. If you really have some pinch point areas, it's best then, maybe you, in this case, you don't use a full tractor trailer truck, use a shorter trailer around your loading docks. For instance, like today, don't use a 53-foot trailer, use a 28-foot pup instead. Or you might want to use a box truck or something like this in areas so you don't call a deficiency out on your layout. Or if it looks really way too tight, sometimes it's best not to have a vehicle there at all. Don't necessarily call attention to it. So we do want to make sure, again, we have the adequate lanes, all intersections here. Make sure we have rounded corners. Nothing really looks worse than having a roadway that literally has a right angle, sharp 90-degree corner at an intersection. And sometimes folks use commercial roadway products that have the lanes printed on it. But that just, a lot of times that they don't have provisions for intersections, so you'll get these unrealistic, super sharp right turns. But even an automobile would have hard time turning tightly around a right angle corner. The fourth don't is don't make grades too steep, or worse, fail to have proper vertical transitions. Now this actually can occur like here. These issues can occur here like at an overpass, or you might have an underpass, or potentially even a grade crossing. On the screen, I've added here a figure showing here what grade is, and it's rise over run. And you can see that you can come up with, when you know the rise and the run, you can come up with the general percentage of grade. For roadways, we really want to keep, for major highways, and try to keep that grade at about 6%. Though when you're doing like local roadways, you can potentially, do like up to like 10%, or something like a logging road or something like that. You potentially could get a little more if you'd like. The biggest things about grades is not necessarily the percent grade, but the vertical and the transitions at the top and the bottom of the grade. We don't want to have it so abrupt at the bottom that your vehicle actually looks like where the front bumper will hit the roadway surface, or worse, at the top of the grade, the vehicle might get high centered. Here's an example of grade crossing here. Generally here, have brought the rail surface up, the roadway surface transitioning from the ground surface to the rail surface on a relatively level. So here there is again a smooth transition across the rail here. Typically, what happens a lot for model railroads with railroad crossings is that we'll try to bring the roadway up, transition literally right at the roadbed. So we'll have this on the unit track or cork roadbed and trying to go from here up to the profile of the rail here. That ends up creating way too steep of a curve. There's really no way that a vehicle will get up and over that. It becomes too steep, and then we have that high center problem. Instead of starting your transition to your roadway, your transition to the top of the railhead should just really kind of bring be back over here, or over here. So allowing a gentle ramp up. Don't have it too steep, too close. Generally with roadways, the more you can have keep things gentle transitions, the better it looks. And then for overpasses and underpasses, ideally, best thing to do is to have them, especially if your layout is relatively shallow, 1 or 2 couple feet across, is just have these roadways, these bridges, just go straight across. Don't think of trying to vary the grade, transitioning up and down. This will avoid that kind of nasty looking vertical transition at the ends, or the unrealistic roadway ramp. The fifth and last don't is don't overcrowd your roadways. Model railroaders, we tend to collect model cars and trucks like we do our locomotives and cars, and we buy them. We spend a lot of money for them potentially, so we want to show them off and have them on roadways. This a lot of times can create unrealistic, overcrowded roadways. These roadways are generally a lot of times meant to be a high-speed facility. Yet our amount of vehicles on a roadway indicators no way. This snapshot picture that we're seeing, it's static on our layout. There's no way that actually can actually be occurring. So for like this picture here is typically what you might see on a layout. And you see here there's a dozen vehicles on this bridge, and this roadway is supposed to be representing a roadway 35-40 miles an hour or so as being a highway in an urban area. Now, the spacing here of these vehicles, its scale spacing around, are only about 20-25 feet apart in end scale. You translate this to your appropriate following distance. These vehicles can be moving about 7 miles an hour, which is typically for a stop and go situation. Here, showing there's our seven vehicles on the bridge, and then with this spacing here, this is representative close to like that a 20 mile an hour roadway. The next here is showing about 5 vehicles on the bridge. This is reflecting about a 35 mile an hour, 40 mile an hour speed spacing. And this last picture with only 3 vehicles on the bridge is representing the speeds that we might be close to like 60 miles an hour. So you can see that if you want to trying to model high-speed environment, high-speed highways, you don't need that many vehicles. You shouldn't have that many vehicles. Then you can use this to spread things out, especially since model vehicles now, and a lot of them are frankly expensive. And then lastly here, I've also compiled this into a table. So you can see here for the three major scales, and given that given following distance, here's the approximate inches that you need to space your vehicles out. Now you don't have to be exact here, but just note that again, you need, if you want to simulate something higher speed, and you're going to need to spread your vehicles out, not have them be so close together. Now, of course, you offer your model like an urban freeway that's at afternoon peak conditions. You can space your vehicles a lot closer together, but you can't get them too close, otherwise you literally turn them into a parking lot. So, if you appropriately accommodate roadways when you're doing your track planning process, have the appropriate width for your roadways, don't have any too narrow or impossible situations for your trucks for maneuvering around corners, not making your grades or transitions too steep, or not adding too many vehicles will ultimately improve your realism of your roadways and your entire model railroad.